Hi everyone. So today we are going to go through a tutorial of how to create any image using only sine functions. So last semester I was very confused about Fourier transform, and I tried to understand it and I spent some time on it. So I hope this tutorial will help you better understand the concept. So let's just go directly to the demo of this tutorial. The left image here shows the individual sinusoidal gratings. The image on the right shows the sum of all the gratings. So by adding up all these gratings, we can reconstruct a image. I followed the code on this tutorial, and so I'm going to show you some results. So at first, how to plot a sine function? We can use NumPy. So here we have 1,001 points from -500 to 501. And suppose our wavelength is 200, and we can see the result of the plot look like this. But this is only 1D. In order to do 2D, we need to use the mesh grid function. So if we draw any line here, it becomes this. So this is a 2D sine function. The next part of the code is to do the Fourier transform of this 2D function, 2D image. So there are three lines of code that is doing the Fourier transform. The most important one is in the middle. So this is the code that actually doing the work. The first line and the third line of the code is only to manipulate the result a little bit. So if you want to understand more about the theory, I recommend you go through either the official tutorial of OpenCV, so you can go through this code, and I think this part of the code is doing the similar work, or you can go to check professor's code on Canvas. So let's get back. So the result of the Fourier transform of the left plot should look like this. So we have two dots on the frequency domain. I wouldn't explain how we calculate these two dots. If you're interested, you can do some research online. And so the next part of the code. So what if we have two waves? One has wavelength of 200 and the other one has a wavelength of 100. And also the second wave has a 45-degree of rotation. So if we add up these two gratings, we can get the combination of these two. So this is the plot of the first wave. This is the plot of the second wave. So this is showing the combination of these two gratings. Yeah, it looks kind of complex, but surprisingly, it is not that complicated on the frequency domain, because you remember this pair of dots is the result from the first grating, and this pair of dots comes from the second one. So if you don't believe me, I will just delete this. And yeah, this should be showing only the Fourier transform of this function, of this image. Let's change it back. Yeah, so now this is the Fourier transform of this combination of these two image. So the next part is how we can reconstruct an image by using Fourier transform. So the Fourier transform is to get this image, but what if we do an inverse Fourier transform? So the inverse Fourier transform, if you remember, is to from this frequency domain to the space domain, right? So if we can get all the points and then do an inverse of Fourier transform, we can reconstruct back to the original image. So this is what this code is actually doing. So there are some helper functions defined above. I will explain later. Also here. So there are actually 4 main steps to complete this task. So the step 1 is to create an empty array full of zeros ready to be used for each pair of points. Here are only some parameters that we use to draw the display. So it's not very important. The step 2 is to iterate through the coordinates in coordinates left half. So coordinates left half means the left half of the image, and then we iterate through the coordinates in it. So for each point, find its corresponding point on the right-hand side to complete the pair. So for example, if we know the coordinate of this point, we are very sure about the location of the other point in this pair. And also, if we know the coordinate of this point, we know exactly where this one located, right? And the third step is to, for each pair of points, copy the values of those points from the Fourier transform into the empty array. And the last step is to calculate the inverse Fourier transform of the array containing the pair of points. This gives the sign function grating represented by these points. And by adding it up, finally we can reconstruct the image. So yeah, it took more than a minute to run this code. So for example, the left plot is showing the image of the Earth in grayscale, and this image is the Fourier transform of the Earth. So we don't, we can't get direct we can't get information from this Fourier transform, right? But if we go through like every point from this image, so from the center, like from closer to the center to farther to the center of the image, we can try to reconstruct the original image. So for example, we have different gratings on the left side. And this one is on the right side is the reconstructed image where we try to add up the inverse Fourier transform of every grating. So if we scroll down, so with the sum of all those gratings on the left side, you can see on the right side, the reconstructed image will have more details. If I can be faster. So it looks like a Earth, is it? So hopefully it is. Yeah. Okay. So after like thousands of summation, even 10,000s, it gains more details on it. So we can see the final result here. We successfully reconstructed the image from adding up all the gratings on the left side. Yeah, so this is all the demo for the code from the tutorial. I hope this can give you a better understanding of using Fourier transform. Yeah, have a good one.